Hi, my name is Magdalene Spitzer, and in this lecture today I will be reviewing the feedback loops in the non-gravid female reproductive system. Specifically, I want to emphasize that we are focusing on both the ovarian and the uterine cycles and the complex hormone control systems that influence them. The endometrial lining of the uterus also undergoes a cycle that is controlled by the ovarian hormones. You can see this in the bottom of this diagram on the slide where it's divided into those three phases, and we'll go into all of those in depth. So I will fully describe the phases of each cycle separately, the ovarian and the uterine cycle, and then I'll bring them all together at the end to fully encompass the entire 28-day menstrual cycle and the hormones that control it. Okay, first let's just overview the main hormones that we'll be talking about that control the menstrual cycle. So first, GnRH, the gonadotropin releasing hormone, which is released from the hypothalamus. FSH and LH are released from the anterior pituitary. Their release is stimulated by gonadotropin releasing hormone. And then estrogen, progesterone, inhibin, and AMH are all hormones that are released from the ovaries themselves. In this diagram above, we'll go back to this later, but this summarizes a little bit of the cyclical nature of these hormones. So you can see FSH and LH at the top, and then estrogen, inhibin, and progesterone across the bottom, as well as the development of the ovary itself. And then you can see we're going to take a closer look at 4 little divisions within this cycle, and we'll go into that in the next few slides as well. Okay, so first let's overview the phases of the uterine and the ovarian cycle. Those graphs on the right are just to help you sort of visualize the descriptions that I'm using to describe the cycles. So first, the uterine cycle. This is shown on the bottom, so titled the menstrual cycle. It's the bottom graph. The uterine cycle has 3 phases: menses, the proliferative phase, and the secretory phase. The beginning of the follicular phase of the ovary corresponds to menstrual bleeding from the uterus, so that's during the menses phase. Phase 2 in the uterine cycle is the proliferative phase. The latter part of the ovarian follicular phase corresponds with this phase. And then in the uterus during this phase, the endometrium is adding a new layer of cells in anticipation of pregnancy. The third phase of the uterus is the secretory phase. After ovulation in the ovarian cycle, hormones from the corpus luteum they convert that thickened endometrium that was created in the previous phase into a more secretory structure. So this means that the luteal phase of the ovarian cycle corresponds with the secretory phase of the ovarian cycle corresponds with the secretory phase of the uterine cycle. If no pregnancy occurs, then the superficial layers of the secretory endometrium are then lost during menstruation, and the uterine cycle begins all over again. So let's look at the ovarian cycle. This is above this top graph, and it's divided into 3 phases, which we already mentioned a little bit: the follicular phase, ovulation, and the luteal phase. The first part of the ovarian cycle is called the follicular phase, and it is simply a period of follicular growth in the ovary. This phase is the most variable in length from woman to woman, and it can last anywhere from 10 to 21 days. Once one or more of those follicles have ripened, the ovary releases the oocytes during ovulation, which is the second stage of this cycle. The final stage of the cycle is the luteal phase. The corpus luteum secretes hormones that continue those preparations for pregnancy. And again, if pregnancy does not occur, then the corpus luteum ceases to function after about 2 weeks. And then again, the cycles will start all over again. So I know this is hard to kind of understand separately when you separate the uterine and ovarian cycle because they're so intertwined. But we'll look next at the hormones that guide the events in these cycles, and then we'll put them all together. Okay, So the ovarian steroids that we're talking about primarily exert negative feedback on the hypothalamic pituitary reproductive axis. That can be shown at the diagram on the right. So it shows the hypothalamus that's secreting gonadotropin releasing hormone, which is acting on the anterior pituitary. So an increase in the gonadotropin releasing hormone causes an increase in FSH secretion and LH secretion from the anterior pituitary. We'll pick that up in a minute. So the ovarian steroids that we were talking about exert negative feedback on this axis, but there is one exception to this. So during most of the phases of the ovarian cycle, they're exerting negative feedback back onto the anterior pituitary and to the hypothalamus. The one exception is right before ovulation. So right before ovulation, there's a large increase in the amount of estrogen that the ovaries are producing. We saw that in the last slide with the spike on the graph of estrogen. That increase in estrogen levels actually turns into positive feedback. So there's a positive feedback loop that goes back onto the anterior pituitary that causes an increased release of the hormone LH. This is the LH surge, and this is what triggers ovulation. We'll go into depth on that a little bit more as well. Just to complete the rest of this diagram, once the FSH secretions increase, they act upon the granulosa cells in the ovaries. They inhibit, there's increased inhibin secretion, which plays back as negative feedback onto the secretion of FSH from the anterior pituitary. And then oogenesis and follicular development are continued. At the same time, the theca cells, LH acts on the theca cells to increase androgen secretions. Those act on the granulosa cells, which are enzymatically modify the androgens, which increases estrogen secretion, which pushes along oogenesis and follicular development. And the increase in the concentration of estrogen in the blood plasma starts a negative feedback loop back onto the anterior pituitary and onto the hypothalamus, so affecting the secretions from in the anterior pituitary as well as the secretions from the hypothalamus. Okay, so let's break this down to look at both the ovarian and the uterine cycles at the same time. So we'll start with the early to mid follicular phase. And first, the menstrual cycle begins on day 1. They mark day 1 with the beginning of bleeding because it's a very obvious physical sign, and it can be marked very clearly. So just before the cycle starts, gonadotropin secretion from the anterior pituitary increases, and FSH causes the tertiary follicles in the ovary to mature. The granulosa cells and their thecal cells produce those hormones. Granulosa cells, as a reminder, produce AMH, while the thecal cells produce androgens. And then the estrogen is exerting a negative feedback onto the anterior pituitary gland to inhibit FSH and LH secretion. This prevents the development of additional follicles during the same cycle. So you can see that negative feedback is with the blue arrows going back up to LH. The green arrows indicate positive feedback. So on the lower left side, you can see that estrogen stimulates more estrogen production by the granulosa cells, which allows for more estrogen production, even with the lowering of FSH and LH levels by the negative feedback. So in the uterus at this time and during this phase, menstruation ends during the early follicular phase, and the endometrium begins to grow and get thicker. The cervix can also start to produce a more clear and watery mucus. So let's look at the right of this slide now, the late follicular phase and ovulation. Ovarian estrogen secretion peaks at the end of the follicular phase. This is before ovulation. The rising levels of estrogen plus the increase in progesterone cause this LH surge. At the same time, FSH levels are dropping because of inhibin. So the granulosa cells are secreting inhibin, which acts back through negative feedback onto the anterior pituitary to decrease FSH levels. This LH surge that we described is the trigger for the final steps of oocyte maturation, and this is starts the beginning of ovulation. So about 16 to 24 hours after the peak in LH, that's when we have ovulation. So the egg is swept up into the fallopian tube and carried away to either be fertilized, or if it's not fertilized, then the corpus luteum ruptures and goes through apoptosis or dies. So let's go to the third phase that we divided these into. This is the early to mid luteal phase. So after ovulation, that's where we are right now, the newly formed luteal cells begin to secrete hormones. The corpus luteum is secreting more and more amounts of progesterone, inhibin, and estrogen. And you can see that at the bottom in the purple. Progesterone is the dominant hormone during the luteal phase. Estrogen cells remain much lower than the peak that we saw before ovulation. You'll see, if you refer back to that diagram, that they initially decrease and then they actually rise again. The combined estrogen and progesterone shut off the FSH and LH secretion, and this is done again through negative feedback. Progesterone causes the endometrium to prep for pregnancy, and it secretes lipids and glycogen to nourish a developing embryo in the placenta if pregnancy were to occur. It also thickens cervical mucus. This thickened cervical mucus creates a plug that blocks the cervical opening. I work at an OBGYN currently, and a lot of women at the end of pregnancy will say that, oh, I lost my cervical mucus plug, which can indicate that some phases of labor are starting to occur. Okay, and then we're going to look at the late luteal phase. The lifespan of the corpus luteum is only about 12 days, so if no pregnancy occurs and the egg is not fertilized, then the corpus luteum undergoes apoptosis or cell death. With this degeneration and cellular death, estrogen and progesterone levels fall. And then gonadotropins start follicular development again in preparation for a new cycle. And then it all begins over again. So let's just quickly review some key points before we move on. So as a reminder, during the follicular phase, estrogen is the dominant steroid hormone. This phase occurs before ovulation, and you remember there's a big spike in the estrogen levels that then causes that positive feedback that causes the LH surge and then triggers ovulation. Like we just said, ovulation is triggered by the surges in LH and FSH. In the luteal phase, progesterone is the dominant hormone, even though estrogen is still present. And AMH is produced by ovarian follicles in the first part of the ovarian cycle to prevent too many follicles from developing at one time. And then just a small note, after this reproductive period in a woman's life, then menopause occurs, and this is because there are no more follicles remaining in the ovaries. And because those ovaries are the major source of the ovarian hormones, the hormone levels decline dramatically.